Hello students, in this video let us discuss about three problems related to mass pulley system. So in that the first one, an infinite number of masses are placed on frictionless table in such a way and they are connected via massless strings, okay, in such a way. Now their masses follow the sequence of some m by 2 so on up to m by n factorial. And they are further connected to mass m that hangs over a massless pulley. He is asking to find the acceleration of hanging mass. It is asked on 11th September 2020 shift 1. So now here what he did? Now on a frictionless table, he took a frictionless table. Now he connected the masses, number of masses with massless strings. And their mass is what he said? M. Okay. M by 2. M by 6. So on. M by n factorial. Right. And again what he said? These masses are connected with frictionless string in such a way. Right. And to another end of the string, a mass m is hanged. And he is asking to find the acceleration of this mass. Okay. So for this first let us find out the effective mass. So effective mass means capital M. The summation of these masses itself, m plus m by 2 plus, here he gave m by 6 plus so on. How much he gave? M by n factorial. Now take m as common. 1 plus 1 by 2 plus 1 by 6 plus so on 1 by n factorial. Now I am writing the same in such a way. See, 1 plus. Now here what I am doing means I am adding 1. Okay. I am adding 1. Now this one as it is I am writing. See. 1 by n factorial. And subtracting 1. Adding 1. Subtracting 1. If we remove again we will get the same. Now I am writing same as 1 plus this as 1 by 1 factorial. 1 factorial means 1 into 1 1 plus 1 by 2 factorial 2 into 1 2. Now 6 how could I write? 1 by 3 factorial. 3 factorial means 3 into 2 into 1 no. 3 factorial means 3 into 2 into 1. Nothing but 6 plus so on up to how much he gave? 1 by n factorial. Here minus 1 we kept no, minus 1. Right? Now next, the value of 1 plus 1 by 1 factorial plus 1 by 2 factorial plus so on up to 1 by n factorial is nothing but e. So now substituting the e, now in this place I am substituting e. E, here minus 1 is there, minus 1. So the effective mass is m, e minus 1 we got. Right? Now, in place of these masses, I will draw the effective mass. Okay? Let us redraw the diagram given. Okay? So, how it will be? I am redrawing the diagram. Frictionless table. In place of all that masses, effective mass m. Right? Passing over the pulley. And a mass small m is hanging. We have to find the acceleration of this mass itself only. Okay. Now let us draw the free body diagram. Okay. On this, as usual, reaction force and mg will act. Now the tension in the string due to mass will be away from the body. T tension. Okay, T tension. Now acceleration will be towards the force only, no? Towards the tension itself only. Okay. Now this is horizontal motion. Now no need of considering these vertical forces. Okay. These vertical forces balance each other. Now let us consider these horizontal forces. So according to Newton's law, what we can write? This tension T will be equal to Newton's law M A. Now let us draw the free body diagram for this. Okay. Now here there will be no reaction force. Reaction force means what? Compulsory the force which acts from the contact surface in upward direction. That only we call reaction force. There is no contact surface. So just mg in downward direction, tension in upward direction. Okay. So now here mg will be greater because here now acceleration will be in such a way, because the block is coming in downward direction means mg is the greater force. Next, tension according to Newton's law, we can write ma. Okay. In terms of tension, let us write mg, tension I am sending to this side, ma to this side, minus ma, or we can write m into g minus a. Now this what can I write? M means already here we find it, no? M into e minus 1. So just substitute m into e minus 1. Now from these two equations, equate these two equations. E minus 1 is equal to, sorry, this a I didn't write here, is equal to m g minus a. M strikes off. Now multiply EA minus A is equal to G minus A. A strikes off. Now what remained? EA is equal to G. Or what he asked? He asked to find the acceleration of hanging mass. Hanging mass. So what it becomes? G by A is the required answer. The acceleration of hanging mass. This is asked in 2020 September. Okay. Now let us move for the next question. Okay. So what is the next question? Consider a system of two masses and a pulley. Okay. So now the coefficient of friction between the two blocks and also between block and table is same. Okay. Coefficient of friction between these two blocks and this lower block and table is 0.1. Find the force F that must be given to 0.8 kg block such that it attains the acceleration of 5 meters per second square. Take g as 10 meters per second square. Now see what he gave in the diagram. Just I am drawing these two only. This is 0.8 kg. Okay. He applied external force. Now he kept another block of 0.2 kg on it. Connected bodies. These are connected bodies. Now he is asking, what he is asking, to attain the acceleration of 5 meter per second square, the block 0.8 kg, to attain the acceleration of 5 meter per second square, how much external force you have to apply? F, we have to find out. Now let us draw the free body diagram. First, in this direction applied force is there means, so here I am drawing only for 0.8 kg I am drawing. In this direction applied force is applied. Okay. So now the tension due to this will be in this direction, away from the body. And the friction force. Here friction creates between these two, the surface between these two blocks. And also the friction creates between the table and this block. Understood? Now the friction creates between these surface, between the two blocks. And between these surface, between the block and the table. Now here, the reaction force from 0.8 kg, let us assume as R. Okay. Now the reaction force from these two surfaces, let us assume as R1. Okay. So from this surface, the perpendicular force in upward direction, we call normal force or reaction force R. Now from this surface, let it be R1. Now the applied force is in this direction, no? So the friction force will act in such a way. I am drawing here again 0.8 kg. This is R. F. Tension. Mu R. Friction force. Formula what? Mu N or mu into R. Coefficient of friction into normal reaction. The formula. I think you remember. We learned in friction. Okay. Now next. One friction force. Again on this block, this friction force also acts, no? The friction created between the two blocks. So that friction force, R1 is the reaction force, no? So mu R1. I hope you understood the free body diagram. Applied force he gave in the diagram. Tension force. Now the reaction force for 0.8 kg from this surface R. So friction force acts opposite to the applied force mu R. Now friction is also present between these two blocks and the reaction force from this surface is R1. So the friction force becomes between these two surfaces mu R1. Right? I think hope you understood. Now let us write the equation. Okay? Equation of motion. Equation of motion for 0.8 kg. Now, the next thing, we have to know the downward gravity force in such a way for 0.8. For 0.8. What it becomes? mg, no? Actually, it is nothing but mg. But what is the value of m? So, actually, it is mg. But what is the value of m? One is 0.8 and this 0.2 is connected to this 0.8, no? So, 0.2, right, acts in a downward direction, right? So, now let us write the equation of motion for 0.8 kg. Okay, if you write for 0.8 kg, what happens? F is the greater force compared to other. Now, minus T, minus mu R, minus mu R1, according to Newton's law. It will be equal to what? It will be equal to 0.8. M is 0.8. No, for 0.8 we are writing MA. 0.8. What is Newton's law? F equal to MA, no. So F means this. M means 0.8. A. Clear? Now let us substitute the values. Okay. Now what he said? The coefficient of friction either between these two surfaces or between these two surfaces is nothing but 0.1. Here he gave 0.1. So, F minus T minus 0.1. Now, R means from here, no. So, mass becomes 0.8 plus 0.2. R is equal to the downward force. Here what I said, 0.2 is in contact to 0.8. So the total mass becomes 0.8 plus 0.2 into G minus mu is 0.1. Now R1. Okay, this is only for 0.2 kg, no? So 0.2 into G. Right? That is equal to 0.8 A. Let us simplify now. Just a simple simplification. A acceleration he gave as 5. Let us put that also. F minus t minus 0.1. 0.8 plus 0.2, 10 into g is minus. Now 0.1 into 0.2. Okay. 1 into 0.2 g is equal to 0.8 into acceleration. How much he said? 5. And g how much he is saying? To take as 10. Let us substitute that g also. F minus t minus 0.1 into 10 into 10 minus 0.1 into 0.2 into 10 is equal to 0.8 into 5. Okay. Now if we simplify all this, we will get F minus t is equal to 5.2 we will get. If we simplify this, we will get F minus t equal to 5.2. Right? 1. Put it as equation 1. Now for 0.2, let us draw the free body diagram. Now here is the surface between these two bodies. No, I am saying this as R1. Okay. Now for this, the tension T. So frictional force will be in this direction. Frictional force. The value of frictional force mu R1. And in downward direction mg. Here what is mg? 0.2 no m. 0.2 he gave into g. Now let us write this for equation of motion. Now equation of motion for 0.2 kg. So how we will write the equation of motion for 0.2 kg? Okay, equation of motion for 0.2 kg. That is nothing but T, okay, minus mu R1 is equal to, according to Newton's second law, MA. What is M? 0.2 into A. Now substitute all values. No, mu 0.1 into R1. Okay. So what is R1? From this diagram, 0.2 G. Now substitute A and G values. G he said to take as 10. A he gave as 5 meter per second square. If you simplify, you will get the T as 1.2. Now substitute these T in equation 1. You want force? No. Then you will get the force F, okay, given to 0.8 kg block. So F minus T equal to 5.2. F minus 1.2 equal to 5.2. We want F force 5.2 plus 1.2. How much you will get? 6.4 newtons is the required answer. Okay. This is about the question asked in 2019 3rd May shift 1. Now next let us move for the third question. Okay. So consider the system of blocks X, A, B as shown in figure. Okay. This is block X. A and B have equal masses. He said A and B. B is in such a way attached to this wall C. Okay. I have equal mass. Okay. You think MA equal to MB. They are connected to a massless string through a massless pulley. Okay. The coefficient of friction of block A and X means here, and X and B. Both is what he gave 0.5. If block X moves on horizontal frictionless surface, so it is moving in such direction, you think acceleration A you assume. Okay, then what should be its minimum acceleration, assume as A, such that A and B must not move. This must remain stationary. For that, how much acceleration is required, he is asking. Right? This is the question. So the first one, he gave MA equal to MB equal to, assume as M. Coefficient of friction as 0.5. So first, what he said, A and B must remain stationary. For that, how much acceleration you have to give to this X block, he said. So first let us think that B has to remain stationary. When block is moving, B must remain stationary. Now, for any object, for example, I'm taking this pen. Now, this must remain stationary without moving in such a way. What we will do, we will apply the force in such a way. When we apply the force, two forces equal and opposite to each other, then the block remains constant and it will not move. Alright? So, in such a way, now in order to make the block B to remain stationary, what must happen? The force on block B, the tension on block B must be equal to the friction force on block B. Right? That is the tension of block B, you assume as T. What will be the frictional force formula? F proportional to R. F is equal to mu R. No. So, mu R. Right? So, T is equal to mu. Now, what will be the R? Okay. According to Newton's law, this must be equal to M into A. Right? M into A, where R is the normal reaction force. Okay? Normal reaction force. Now, next, put it as equation 1. Now, next, let us talk about A to be stationary. The same concept applies here also. So, in order to be A to be stationary, the friction force, so here for block B, here the friction force will act. For block A, here the friction force is there. So, the friction force must be equal to, one is the tension, the sum of tension force applied on the block A and the external force or applied force. Okay? The block will come in such a way, no? The applied force. So, the friction force formula, mu. Okay, now this will be the R and mg acts in downward direction. So, mu R is equal to tension force T. Applied force will be according to Newton's law. Okay, first let us write it as F. Now, mu into R will be equal to mg. Now, here, this will be the R and MA. Okay. Now, mu mg is equal to T plus, according to Newton's law, M into A we will write. Right? And tension force, okay, will be equal to, here we find it, no, mu into MA plus MA. Now, M you take as common, mu A plus A. MM strikes off. Now, what remained? Mu G is equal to mu A plus A. But what we want? A, no. Write a whole equation in terms of A, no. Mu plus 1. A equal to mu G by mu plus 1. Mu he said common between either A and X or B and X. Common he gave as 0.5. 0.5. Now G, acceleration due to gravity, 0.5 plus 1. So 0.5 G by 1.5. How much you will get? 5, 3 is 15, no. Okay, G by 3. So this much minimum acceleration if you can apply, then these two blocks A and B remains stationary. So this is the question asked in 2019 3rd May shift 1. So these are about mass pulley system questions PYQs of EAPCET asked in previous years. If you like my video, share it, subscribe it, and while subscribing, don't forget how to activate the notification bell. Thank you.